Students, am I audible?
Yes, sir.
Okay, okay. Actually, today's topic is harmonic analysis. So usually in real life data, we won't get any continuous function. We'll be getting only discrete data. For example, or I can say the population in a particular year. For example, 2000, 2001, 2002, 2003, and so on up to 100 years. 100 years. Okay. For each year, we can say what is the population. What is the population in the particular year? Okay, that means xi is the year and then corresponding the population is yi. Xi is given and yi is given. This gives some discrete data. This gives some discrete data. Okay, for this kind of problems, uh, suppose if it is a periodic, for example, for at the year 2000, the population is one value. Similarly, at the 2020, the population is same means we can say it is a periodic function. Now one can extend this discrete data into a some continuous function by using trigonometric series or Fourier series expansion. Okay, so this is some application point of view. One can say one can extend a discrete set of data into the continuous function through Fourier series. Fourier series. Okay, fine. Now, see today's topic is harmonic analysis. That is f of x is some function. Here we are going to give only the discrete data. Now this f of x is approximated as a Fourier series up to the nth harmonic. We call this as nth harmonic. Nth harmonic means an cos nx plus bn sin nx. That is called nth harmonic. And the first harmonics a1 cos x plus b1 sin x. This is called the first harmonic or fundamental harmonic. Okay, these are all one mark questions. First harmonic or fundamental harmonic. And then second harmonic is a2 cos 2x plus b2 sin 2x. Third harmonic is a3 cos 3x plus b3 sin 3x and so on. Similarly, the nth harmonic is an cos nx plus bn sin nx. This is called harmonic. Definition of harmonics. Now, as I told you, we are getting only, see, we have only discrete data. See, therefore, we are going to have some summation rule or summation formula to evaluate a0, an, bn, all these things. For this, I applied the trapezoidal rule to approximate the formulas of a0, an, bn. By using the trapezoidal rule, one can approximate a0 as 2 by m summation I equal to 0 to m minus 1 into yi. Here yi is nothing but f of xi. And a1 is 2 by m summation I equal to 0 to m minus 1 yi into cos xi. Similarly, a2 is 2 by m into summation I equal to 0 to m minus 1 yi cos 2xi. In general, an is 2 by m summation I equal to 0 to m minus 1 yi into cos nxi. This is for the formula for an. Similarly, for b1, 2 by m summation I equal to 0 to m minus 1 yi sin xi. For b2, 2 by m summation I equal to 0 to m minus 1 yi into sin 2x. In general, the bn is 2 by m summation I equal to 0 to m minus 1 yi into sin n xi. Okay, here m is the number of subintervals in the given interval. Say for example, if you are solving the problem in the domain 0 to 2 pi, for example, this is a domain 0 to 2 pi. Now we are going to have a nodes at this interval. For example, node 1, node 3, node 4, and so on. This is m minus 1th node. This is mth node. That means we divide this interval into m subintervals. If you divide this interval into m subintervals, there will be m plus 1 points. Okay, see here m is nothing but the number of subintervals in the given interval. M is the number of subintervals in the interval. Okay. Now after After rewriting this, we come to the table. See, for this problem, we have to form the table like this. First x value. Usually we used to give only either 6 or 12 or 18 like this. We will give the data, 18 data or 6 data or 12 data or 18 data like this only. Okay, for convenient. Say for example, our domain is 0 to 2 pi. See, therefore, this domain is divided into some 6 subintervals. See, therefore, what will be the first value? For example, if I divide into 6 subintervals, then the first value will be pi by 3. Pi by 3. This is pi by 3. 2 pi divided by 6. 2 pi divided by 6 is pi by 3. Okay, pi by 3. Then the second value is 2 pi by 3. Then the third one is pi, and the fourth one is 4 pi by 3. Okay, and the fifth one is 5 pi by 3. 5 pi by 3. Okay, now how many intervals? There are 6 intervals. 1, 2, 3, 4, 5, 6 intervals. That is m equal to 6 here. Okay, fine. Now, after identifying what are the nodes, you have to calculate sin x, sin 2x, sin 3x, cos x, cos 2x, cos 3x, because in most of the problems they will give you only find the approximation up to the third harmonic only. Find the approximation up to the third harmonic only. And then y sin x, y sin 2x, y sin 3x, y cos x, y cos 2x, and y cos 3x. Okay, see, this is the last one is the y cos 3x. Why? Because we need all these expressions. See, we have, while calculating a1, we need summation y cos x. While calculating a2, we need y cos 2x. For a3, we need y cos 3x. For b1, we need y sin x. For b2, we need y sin 2x. For b3, we need y sin 3x. See, therefore, you form the table like this. Please, all of you take your calculator, because we need a calculator for calculating, to fill up this table. Please take your calculator, okay? Yes, see, now for x equal to 0, what will be the sin 0? Sin 0 is 0. For x equal to pi by 3, the sin is 0.866. For x equal to 2 pi by 3, sin value is 0.866. For x equal to pi, sin pi is 0. Okay, for x equal to 4 pi by 3, this is minus, sin value is minus 0.866. Okay, please fix your calculator in radian mode. If you fix your calculator in degree mode, these values will be different. You won't get the correct answer. Okay, because I am giving only the radian value, radian mode. Okay, now 4 pi by 3, for x equal to 4 pi by 3, this is minus 0.866, and for x equal to 5 pi by 3, then the value is minus 0.866, because sin x is a periodic function. Similarly, if I substitute x equal to 0 in sin 2x, sin 2 into 0, which is sin 0, so again 0. See, therefore here, now sin 2 into pi by 3, that is sin 2 pi by 3. Sin 2 pi by 3 is 0.866. Similarly, sin 4, because this is a sin 2x column, you plug this expression, plug the value of x here. Now sin 4 pi by 3, which is minus 0.866, and sin 2 pi, which is 0, sin 8 pi by 3, which is 0.866, because sin 2x is also periodic function, and sin 10 pi by 3, which is minus 0.866. Okay, and sin 3x will be 0, because sin 0, 0, sin pi, which is 0, sin 2 pi, which will be 0, sin 3 pi is 0, sin 4 pi 0, and sin 5 pi is also 0. Since we have seen sin n pi, which is equal to 0 for any n. Okay, and now come to the cos x column. What is cos 0? Cos 0, which is 1. Cos pi by 3, which is 0.5. And the cos 2 pi by 3, which is minus 0.5. And the cos pi, which is minus 1. Cos 4 pi by 3, which is minus 0.5. And the cos 5 pi by 3, which is 0.5. Okay. Similarly, now come to the cos 2x column. For cos 2x column, here this is cos 2 0, that is 1. Cos 2 pi by 3, which is minus 0.5. And the cos 4 pi by 3, which is minus 0.5. 5, and cos 2 pi, which is 1, cos 4 pi by 3, which is minus 0.5, cos 10 pi by 3, which is minus 0.5. Now come to the cos 3x column. What is cos 0? Cos 3 times of 0. This is cos 0, 1. And cos 3 into pi by 3, that is cos pi. This is negative 1. And cos, what is this here? Cos 2 pi by 3 into 3, that is cos 2 pi. Therefore, this is 1. And cos 3 pi, this is negative 1. Cos 4 pi, which is positive 1. And cos 5 pi, which is negative 1. Okay. See, this is the fundamental table. Okay, fundamental table. First, you have to write down this table for all the problems. For all the problems, first you form the table like this. First, form the table like this. Then we will fill it up later. Okay, fine. So I repeat, M is the number of subintervals. Okay, guys. While solving the problem, I will give you some note. Yeah, first problem. And some basic definition. These are all 1 mark questions. First one, fundamental harmonic or first harmonic. Fundamental harmonic or first harmonic. It is A1 cos x plus B1 sin x is called the first harmonic. First harmonic. And its amplitude is, that is, we call this as A1, which is under root A1 square plus B1 square. And the second definition, second harmonic. Second harmonic or octave. Okay, octave. This is A2 cos 2x plus B2 sin 2x is called the second harmonic. Second harmonic. And its amplitude is A2, this is equal to under root A2 square plus B2 square. Okay. So similarly, the third harmonic is A3 cos 3x. Okay. A3, once again. This. The third harmonic is A3 cos 3x plus B3 sin 3x. Okay. And its amplitude A3, which is equal to under root A3 square plus B3 square, and so on. Okay. See, these are some important definitions. I'll give some problem. Yes, the first problem is find the Fourier series up to the third harmonic from the following data. Find the Fourier series up to the third harmonic, from the following data. That is, x value is given and y is equal to f of x. Here 0, pi by 3, 2 pi by 3, this is pi, 4 pi by 3, and 5 pi by 3, and this is 2 pi. Okay, and this is 1, 1.4, 1.9, 1.7, and 1.5. This is 1.2, and this is 1. Okay. So look at the data. This is from the data. One should identify the given data is a periodic data. Periodic data. Look at this. At x equal to 0, the value of y is 1. Similarly, at x equal to 2 pi, the value of y is also 1. See, therefore, it gives some periodic function. Periodic function. See, therefore, one can extend this function into a harmonic series. Now, look at this. We have to express this data into a continuous function up to the third harmonic. Means that is f of x is approximated as a0 by 2 plus a1 cos x plus b1 sin x plus a2 cos 2x plus b2 sin 2x plus a3 cos 3x plus b3 sin 3x. This is called expressing the function up to the third harmonic. Suppose if they are asking up to the second harmonic, means a0 by 2 plus a1 cos x plus b1 sin x plus a2 cos 2x plus b2 sin 2x up to this. If they are expecting only up to the fundamental harmonic, means a0 by 2 plus a1 cos x plus b1 sin x. That's all. Okay, fine. See, these are some important things. And one more thing, see, this data is a periodic data. This data is a periodic data. See, therefore, you ignore the last value. Okay, if there are 7 data are given, for example, 1, 2, 3, 4, 5, 6, 7 data are given, then ignore the last data. Because this function is a periodic function. See, therefore, the function represents the same value at x equal to 0 as well as x equal to 2 pi. See, therefore, one can ignore the last value. Okay. Suppose if this is missing, first you have to include this data at x equal to 2 pi, which is 1. Then calculate your m. M is nothing but what? M is nothing but number of subintervals. Look at this. How many intervals? 0 to pi by 3 is one interval, pi by 3 is to 2 pi by 3 is another interval, then 2 pi by 3 is to pi is the third interval, pi to 4 pi by 3 is the fourth interval, this is the fifth interval, and this is the sixth interval. From the data itself, you have to identify what is your m. M is nothing but the number of subintervals, because m playing a very important role while calculating a0, an, and bn's. Okay? So usually we used to give either 6 data or 12 data. Okay, so therefore either m will be 6 or 12. So please keep it in mind. Okay, now see solution here m equal to 1. Sorry, m equal to 6. Here m equal to 6 because there are 6 intervals are given. And then you have to write down the table up to 5 pi by 3. Don't include the value of f at x equal to 2 pi. I repeat, because the data is a periodic data. See, therefore, you should ignore the value of f at x equal to 2 pi. See, that is why I didn't write the value of f at x equal to 2 pi. Okay? Yes. Now, see, this x values are given: x equal to 0, x equal to pi by 3, x equal to 2 pi by 3, x equal to pi, x equal to 4 pi by 3, and x equal to 5 pi by 3. Okay. Now, see, this is your y or f of x. Y or f of x. See, can you able to hear me?
Yes, sir.
Okay, fine. Now here, y is given, y column is this one. First write it from 0. What is the value of y at x equal to 0? This is 1, okay? This is 1. See, therefore, first value is 1. And then at x equal to pi by 3, the value is 1.4. See, therefore, this is 1.4. At x equal to 2 pi by 3, this is 1.9. See, therefore, this is 1.9. At x equal to pi, the value of y is 1.7. See, therefore, this is 1.7. At x equal to 4 pi by 3, this is 1.5. Okay? And at x equal to 5 pi by 3, this is 1.2. Okay? Now, you have to multiply this column with this column and put it in this column. Similarly, multiply this column with this column and put it in this column. Okay, we'll do it now. Please help me. Here y equal to 1 and sine value is 0, so therefore 1 into 0, which is 0. Okay, and y equal to 1.4 and sin x value is 0.866. See, therefore what is the value? 1.4 into 0.866. Can you please tell me what is this? Correct up to 2 decimal places. 1.4 into 0.866.
1.21.
1.21. Okay, very good. Then 1.9 into 0.866. 1.9 into 0.866. Please tell me what is this 1.9 into 0.866 and up to 2 decimal places. Yes.
So 1.65.
Yeah, this is 1.65. Okay, 1.65. Now 1.7 into 0. 1.7 into 0, this is 0. And 1.5 into minus 0.866. Tell me what is this value? 1.5 into minus 0.866.
1.30. 1.30.
1.30. 1.30. Okay. Or 1.299. Okay, 1.29, right? Am I right? Then here 1.2 into minus 0.866. 1.2 into minus 0.866. What is this value?
1.04.
1.04. Okay, 1.05. Now come to the y sine 2x column. Y is 1 and sine 2x is 0. See, therefore this is 0. And 1.4 into 0.866. See, therefore this is again 1.21. And 1.9 into minus 0.866. See, therefore minus 1.65. 1.7 into 0. See, therefore this is 0. And 1.5 into 0.866. See, therefore positive 1.29. And then 1.2 into minus 0.866. See, therefore minus 1.04. Okay. Now come to the y sine 3x column. Y sine 3x. Y sine 3x is always 0. Okay. Sine 3x is always 0. And then see, therefore this becomes 0, 0, 0, 0, 0 and 0, 0 here. Now come to y cos x. Y cos x. What is y cos x? Y is 1 and cos x is 1. See, therefore 1 into 1, 1. Y is 1.4 and cos x is 0.5. Cos x is 0.5. See, therefore what is this? 1.4, 0.7. Okay, thank you. Now 1.9 into minus 0.5. See, therefore minus, what is this?
0.95.
0.95. Okay, 0.95. And then 1.7 into minus 1. See, therefore minus 1.7. Here 1.5 into minus 0.5. Therefore minus
0.75.
0.75. Okay. Now 1.2 into 0.5. 1.2 into 0.6.
0.6.
0.6. Okay, 0.6. Fine. Now y cos 2x. y is 1, cos 2x is 1, so therefore this is 1. And y is 1.4, this is minus 0.5, so therefore minus 0.7. Okay, and 1.9 into minus 0.5, so therefore minus 0.95. Okay, and 1.7 into 1, so therefore 1.7. Here 1.5 into minus 0.5, so therefore minus 0.75. Okay, and 1.2 into minus 0.5, so therefore minus 0.6. Now y cos 3x, 1 into 1, 1, and then minus 1 into 1.4. Okay, therefore minus 1.4. 1.9 into 1, so therefore 1.9. And 1.7 into minus 1, so therefore minus 1.7. 1.5 into 1, so therefore 1.5. And 1.2 into minus 1, so therefore minus 1.2. Okay, we filled all these things. Now calculate the summation. This is the summation column, summation row. This is the summation row. Now calculate what is y summation y. You add all these things and tell me what is this value here. What is summation y? Here, summation y. 1 plus 1.4 plus 1.9 plus 1.7 plus 1.5 plus 1.2.
8.7.
Yeah, this is 8.7. Now summation y sin x. Summation y sin x.
0.53.
0.53. Yeah, 524. Huh?
Yes, sir.
524. And y sin 2x. Yeah, someone. Yeah, y sin 2x. Y sin 2x. Anyone please, what is y sin 2x?
1.89. 1.89.
1.89.
Minus minus
Yeah,
0.18.
minus 0.1.
1.8.
Okay, 18 or 178. Okay, 178. This is minus 0.178. Okay, and summation y sin 3x is 0 because all the values are 0 here. Now, what is y cos x? Summation y cos x. Summation y cos x.
Minus 0.9.
Not minus 0.9. Is, I think it is minus 1.1. Please verify it. Minus 1.1. Okay, and y cos 2x. Y cos 2x.
Minus 0.3.
Minus, yeah, minus 0. Yeah, minus 0.3. And y cos 3x.
0.1.
Yeah, this is 0.1. Okay, we got all this data. Now come to your A naught. A naught, which is 2 by m summation yi. Okay, but m equal to 6. Therefore, this is 2 by 6 is 1 by 3. 1 by 3 into summation. What is summation yi? This is a summation row. Summation row. This is summation yi. See, therefore, 1 by 3 into 8.7. What is this? 1 by 3 into 8.7. Sorry, 1 by 3. 1 by 3 into 8.7. 2 point. This is 2.9. Okay. Am I right?
Yes, sir.
And A1, which is 1 by 3 into summation y cos x. Okay, that is 1 by 3 into, what is y cos x? Y cos x is minus 1.1. Minus 1.1. So therefore, this is minus 0.367. A1 is minus 0.367. And A2, which is 1 by 3 summation y cos 2x. This is 1 by 3 into, what is y cos 2x? Y cos 2x is minus 0.3. Minus 0.3. See, therefore, minus 0.1. And A3, this is 1 by 3 into summation y cos 3x, which is 1 by 3 into, what is y cos 3x? Summation y cos 3x is 0.1. 0.1. See, therefore, this is 0.033. Okay. Now come to B1. What is B1? This is 2 by m summation y sin x. That is 1 by 3 into summation y sin x is what? This is 0.524. 0.524. See, therefore, this gives 0.175. And B2, this is 1 by 3 into summation y sin 2x. That is 1 by 3 into, what is y sin 2x? Y sin 2x is minus 0.178. Okay. What is this value? This is minus 0.05, minus 0.059. Okay. And B3, which is 1 by 3 into summation y sin 3x. This is 1 by 3 into 0, because summation y sin 3x is 0. Okay, fine. Thus you have calculated all the constants required for the Fourier series expansion. Now look at this. We are going to write down the approximate expression, approximate solution for the given data data set. That is, f of x is approximated as a naught by 2. Okay. What is a naught? A naught is 2.9. So therefore 2.9 by 2 plus, what is A1? A1 is minus 0.367. Minus 0.367 cos x. And B1 is 0.175. Is this visible?
No, sir.
Yeah, I will write it in some other place. Okay, I will write it here. That is, my f of x is approximated as a naught by 2. That is, a naught is 2.9 divided by 2 plus, what is a1? A1 is minus 0.367 minus 0.367 cos x plus B1 is 0.175 sin x. So this is the up to first harmonic. Plus A2 is what? A2 is minus 0.1 cos 2x and B2 is minus 0.059 sine 2x. This is up to the second harmonic. Okay. Then next step is 0.033 cos 3x plus 0 into sine 3x. So this is up to the third harmonic. This is the harmonic or Fourier series expansion up to the third harmonic. Okay. So this is the procedure. Is there any doubt? Any doubt? Any doubt in this problem?
No, sir.
Okay, if there is no doubt, then I will go for the next problem, next type of problem. Okay, usually they will give the data like this. Okay, sometimes they will give the data in terms of some real number. For example, at x equal to 0, this, at x equal to 1, y is this, at x equal to 2, the y is this, x equal to 3, the y is this, like this. They will give in terms of real numbers, okay. First you have to convert that real numbers into the number like in terms of pi. It is called radian values in terms of pi by using some formula. Okay, then calculate like this. So second problem. Find the Fourier series up to the second harmonic, from the data. Okay, x is given and the corresponding f of x is given. Okay, this is 0, 1, 2, 3, 4, 5, and this is 9, f of x is 9, this is 18, 24, 28, 26, and 20. Okay, see, as I told you, we are going to express the given data into the Fourier series expansion. See, therefore the function should be periodic function. Now compare the last value and the first value. If they are same, leave it. Otherwise, we have to include one more data in order to make that data into the periodic data. Okay. Look at the last data. This is at x equal to 0. This is 9, whereas here it is 20. See, therefore this is not preserving the periodic data. See, therefore first we have to include one data in order to make the data into a periodic data. That is, at x equal to 6, the value of f is 9. See, this is not given in the problem, but we are introducing in order to make the data into periodic data. Okay, after introducing this, now tell me what is the number of interval. See, this is the first interval, second interval, third interval, fourth interval, fifth interval, and sixth interval. Okay, so therefore m equal to 6. For this problem also, m equal to 6. That is number of intervals, which is 6. Okay, fine. Now look at the data given in terms of the real numbers 0, 1, 2, 3, 4, 5, 6. Of course, these are also real number. I agree. Okay, 0, pi by 3, 2 pi by 3, 5 pi by 3. They are also real numbers, but it has some specific numbers. They are integers. Okay. First, we have to convert these numbers into the form in terms of pi. Now use the formula. That is, use theta, which is equal to 2 pi x divided by the last value minus the first value in the x argument. The last value minus the first argument, that is 6 minus 0. That is, the formula is 2 pi x divided by 6. 2 pi x divided by 6, or this is pi x divided by 3. Pi x divided by 3. Now look at this. Here this is x equals 0, 1, 2, 3, 4, and 5. Now you have to change, this is theta, and this is sine theta, and this is sine 2 theta, sine 3 theta, cos theta, cos 2 theta, cos 3 theta, and then this is y sine theta, y sine 2 theta, and y sine 3 theta, y cos theta, y cos 2 theta, and this is y cos 3 theta. Okay. Now, for x equal to 2, what is the formula for theta? Theta is pi x by 3. Okay. Theta is pi x by 3. See, therefore, for x equal to 0, what is theta? Theta is 0. For x equal to 1, the theta is pi by 3. For x equal to 2, the theta is 2 pi by 3. For x equal to 3, the theta is pi. For x equal to 4, this theta is 4 pi by 3. X equal to 5, this is 5 pi by 3. Then all these data which are same. All the data which are same. Guys, in examination, you have to write down this full table. This full table. We won't provide this table, okay? We have to write down the table. Now, we have to change these values. This is because y values are different, you know. Y values are different. So therefore, we have to change all these data. And the second thing is, they are asking, you have to express the data into up to the second harmonic. So therefore, no need to calculate y sine 3x and y cos 3x. Okay. Okay, fine. Now please help me. What is y? Y is 9, 18, 18, 24, 28, 24, 28, 26, and 20. Okay, we are ignoring the last value because this data is periodic data or repeated data. We have to remove the repeated data. Fine. Now tell me, what is y sine theta? Y is 9 and sine theta is 0. See, therefore this is 0. Okay, please tell me, what is this? This column, 18 into 0.866. 18 into 0.866.
15.58.
Yeah, this is 15.58. Okay, thank you. And 24 into 0.866. 24 into
20.78.
Okay, now 28 into 0, this is 0, and 26 into minus 0.866. 26 into minus 0.866.
Minus 22.51.
51, actually 516, okay? Therefore 51, I'll make it as 52. Okay, now 20 into minus 0.866. 20 into minus 0.866.
17.32.
Minus 17.32, okay? Minus 17.32, fine. Now y sine 2 theta. Y is 9, sine 2 theta is 0, so therefore this is 0. And y is 18, and this is 0.866, therefore 15.58. 15.58. 24 into minus 0.866, therefore minus 20.78. And 28 into 0, so therefore this is 0. and 26 into 0.866, see therefore 22.52, okay, and 20 into minus 0.86, see therefore minus 17.32. And I don't want this y sine 3 theta because we are going to express this data up to the second harmonic. See, therefore, I don't want this as well as this. Now come to y cos theta. Y is 9, cos theta is 1, see, therefore, this is 9. And y is 18, cos theta is 0.5, see, therefore, again, this is 9. Am I right? And this is 24 cos theta is minus 0.5, see, therefore, minus 12, okay, and 28 into minus 1, so therefore minus 28, and 26 into minus 0.5, so therefore minus 13, okay, and 20 into 0.5, so therefore this is 10. Now y cos, sorry, I wrote it here. I should write here, this is 9, minus 12, minus 28, minus 13, 10. This should be empty. Yeah, and y cos 2 theta. Y cos 2 theta is 9 into 1, this is 9, and 18 into minus 0.5, this is minus 9, and 24 into minus 0.5, so therefore minus 12, and 28 into 1, this is 28, okay, and 26 into minus 0.5, so therefore minus 13, and 20 into minus 0.5, so therefore this is minus 10, okay, and I don't want this. You please sum it up and tell me what is this summation y. What is the summation y?
$125.
Yeah, this is 125, and y sine theta.
minus 3.48.
Minus 3.46, okay, minus 3.464. Please verify it. Minus 3.464. And y sine 2 theta. Y sine 2 theta.
Sir, 0.
Yeah, this is 0. Okay, this is 0. And y cos theta. Y cos theta is
Minus 45.
minus 45. Minus 45 or 25?
25, sir.
Minus 25. Okay, minus 25. And y cos 2 theta.
Minus 7.
Yeah, this is minus 7. Okay, very good. Thus, we have calculated all the summations. Now, plug this expression in your formula. Now, tell me what is your A naught? Actually, our M equal to 6 here. See, therefore, A naught equal to 1 by 3 into summation y. Summation y is 125. Okay, what is this? A naught is 41.67. And the A1, this is 1 by 3 into summation y, y cos theta. Y cos theta is minus 25. Minus 25. See, therefore, this is minus 8.33. Okay. And A2, which is 1 by 3 into summation y cos 2 theta. Y cos 2 theta, which is negative 7. See, therefore, this is minus 2.33. Now, our B1, which is, what is our B1? 1 by 3, 1 by 3 into summation y sine theta, that is minus 3.464. See, hence it is minus 1.15. And B2, which is 1 by 3 into summation y sine 2 theta, it is 0. See, therefore, this is 0. Okay, we have calculated all the Euler constants. Now, our f of x is approximated. F of x is approximated as a0 by 2, that is 41.67 divided by 2, plus a1, that is minus 8.33 cos theta minus 1.15 sin theta, okay, plus a2 is minus 2.33 cos 2 theta plus 0 into sin 2 theta. Okay, remember we transformed the problem from the variable x into theta. So therefore we have to write it down in terms of theta. Okay, of course theta is nothing but what? Theta is nothing but pi x by
3.
pi x by 3. Okay, you can replace it. It is understood. Here you just write down theta equal to pi x by 3. That's all. Okay. Is it clear?
Yes, sir.
Okay. Then I will give another third problem. You take it as an exercise. I will give the idea how to solve this problem. Okay. The only thing is you have to transform. The variable into theta variable. That is a trick. The third problem is find the Fourier series up to the second harmonic from the following data. Okay, here t seconds are given and then the corresponding voltage in amp actually. So this is a 0, t by 6, t by 3, and this is a t by 2, 2t by 3, 5t by 6, 5t by 6 and t. And then the corresponding amp at t equal to 0, this is 1.98, 1.30, and this is 1.05, and this is 1.30, minus 0.88, minus 0.25, and this is 1.98. Okay. Yeah, you please compare the first value and the last value. This is 1.98. This is also 1.98. See, therefore, this data represents the periodic data. Okay, this data represents the periodic data. Then how many intervals are there? There are first one interval, 2, 3, 4, 5, 6. See, therefore, in this problem also, the number of intervals is 6. That is m equal to 6. Okay, m equal to 6. As I told you, the first value and the last value are same. They are repeated data. See, therefore, you have to ignore this last data. Okay, and you have to use the transformation t, which is 2 pi t divided by capital T minus that is this t minus this 0, that is 2 pi t divided by capital T. Now See, this is your t value. T value is 0, and this is t by 6, and this is 2 t by 3, and this is 2 t by 2, 2t by 3, 2t by 3, and 5t by 6. Okay, 5t by 6. So as I told you, you have to ignore this value because these two are same. First value and the last value are same. See, therefore, we should ignore this. And then what will happen when we substitute t equal to 0, then what is this formula? This formula is 2 pi. This is 2 pi t divided by capital T. Okay. Now, what will happen when we substitute t equal to 0? This is 0. When we substitute t equal to small t equal to capital T by 6, what will happen? That is a small t which is equal to a capital T by 6, which implies what is theta? Theta is 2 pi into t divided by 6 into t, that is tt gets cancelled, and then this is 3. See, therefore pi by 3. We got pi by 3. Similarly, if t equal to t by 3, which implies what is theta? Theta is 2 pi t divided by 3 into capital T. T gets cancelled, then 2 pi by 3. Okay, 2 pi by 3. Similarly, if t equal to small t equal to capital T by 2, then this will be pi. If small t equal to 2t by 3, then this will be 4t by 3. Similarly, if small t equal to 5t by 6, then theta will be 5 pi by 3. Then all these data which are same, the only thing is you have to fill it up to the value of y. Actually, this is y. Okay? This is y. You fill it up here and then write down the data up to the second harmonic. See, this is also important problem. Take it as an exercise. Okay. 1 minute. I'll take the attendance. All of you chart your presence in the chat box.